some problems I think are vital.
Was was C and 858 not possible?
858.
Yeah.
Correct. It's not possible. Actually, it's someone call it an imaginary number, which you'll talk about in algebra 2 next year. But it's not a real answer because we know we can't square root negative numbers. Like you can't multiply two real numbers and make it negative. Like 2 times 2 is 4. Negative 2 times negative 2 is 4 still. But to get negative 4, that'd be weird, right? But yeah, you say no real solution, right? But there's something called an imaginary solution, which you won't learn for another year. For now, just say no solution. That's totally fine. I agree. Um, Also another thing to Nick, since you brought it up, if you're to graph the left side, it's a parabola. You may have done that in middle school, perhaps. If you graph -3, it's a horizontal line that crosses the y-axis at -3. There are no points of intersection. That's another reason why it'd be no solution as well. But these are all things that you'll do next year. Okay. Other questions? Okay, let me just kind of recap some of this stuff here. For 853, that's new stuff. So remember, for an exterior angle, that's 360 divided by n. So n would have to be 18 in this case. Once you have that established, the interior polygons, that's easy. That's 160, not that hard. For 856, equilateral triangle, if you have each side is 20, you guys should be pretty comfortable with breaking it down because that's going to be a big part of finding the area of all these polygons, right?
Yeah.
We're going to have all these triangles. If you have 20, 20, and 20, if you drop the altitude, you clearly make the bottom side cut in half. If you do Pythagorean theorem or know your ratios, you should get 10 root 3. Find the area should be pretty straightforward at that point. 1/2 times the base times the height, 1/2 times 20 times 10 root 3. You would get the answer for 856. For 857, Eiffel Tower problem. Yeah, we're going to be talking a lot about this kind of stuff today. That's why this is in the homework. You guys should be pretty comfortable with um, proportions.
Never.
Guys, thanks. The model built to scale is 128 meters tall, 40 meters wide space. If the real tower, okay, this is in Las Vegas, right? In the Paris Hotel, right? So that's a replica of the real Eiffel Tower. So if it's done to scale, then you would imagine that, okay, well, I'm just gonna draw a triangle because I don't know if like drawing the Eiffel Tower. But say that's Eiffel Tower, right? 128. Sorry, that's the one in Las Vegas. But the one in Paris, if the real tower is 324 feet tall, sorry, that's 324. Then what's that going to be? How would you set that up? You set up a proportion, right? And you should be fine there. Um, yeah, solving the equations, no questions there. Factoring, guys okay with, or quad form? We gotta use quad form for B. For 860, those are the answers there. I don't see the actual question, but the actual question looks like this. You guys are okay with that? Solve for X, right? Parallel lines. Looks like you have 6 angles there. You guys okay? They're all up to 720. Okay, cool. All right. By the way, for D, you could totally figure out this is going to be right here. Because I always have to have the 540. Let's say, I don't know, let's say it's 100 degrees. And that's 100, and X is 100. So just so you know, I don't know what it is exactly. Um, guys, stop talking. Thank you. 861, okay. Okay, fine there. 866, Dean Trigg. All right, let's get to notes then. All right, so if you guys got your thick note packet, we're doing 8.2.1. I'm gonna do the first question with you guys. Just kind of get you guys warmed up, and then I'm gonna have you guys try the rest. Yeah, great question. And actually, no, 20th. 20th. Yeah. So it's on March 20th. A handful of you guys do have multiple assessments that day, so we do need to have a conversation as to
Freshmen or sophomores?
sophomores. Sophomores have a very impacted because it's right for Spirit Week. So it's incredibly impactful for the sophomores because there's like I think U.S. history or civics, what I think it's what you guys call it. And then there's what's the other one? Chemistry as well, and my class.
It's like April. April?
Was that?
April.
Yeah, but then we have spring break after that too. So yeah, I we have to gonna keep it the way it is. But anyway, if you just look at look at what you have going on, come talk to me if you need to consider moving. If you have three or more, I'm open to helping you out. Okay. Oh, and we have a retake this Thursday. I already sent the invites for that. So those who are eligible, that's this Thursday in this room. All right. All right. So let's have someone do some reading. Give my voice a little break here. Anthony, I'll look at you. Why don't you get started? So versus area ratios. The top of 8.21, yeah.
This course is focused on similarity. You have studied how to use proportional relationships to find the measures of size of similar figures. Today you will study how the areas of similar figures are related. That is, as the shape is enlarged or reduced in size. How does the area change?
Hey, thank you, Anthony. So my mascot. To celebrate the victory of your school's championship, girls ice hockey team, the student body decided to hang a giant flag with your school's mascot on the gym wall. To help design the flag, your friend Archie has created a scale version of the flag measuring 1 foot by 1.5 feet. Okay, so this is one. Hold on. So here we go. All right, that's one. And the height is 1.5. Okay. So Archie thinks the final flag should be 3 feet tall. Okay. How wide would the enlarged flag be? Well, how am I gonna set that up? What would I do, guys? So this should be 3 feet tall.
3 over 1.5.
Yeah, exactly. You compare the height of the real flag to the model flag or replica flag. And then of course you do x over 1. That's very easy. Solve for x, you should get 2. So you're 2 feet. So this is just review of like proportions. You guys know this, right? Similar triangles, a lot of that stuff. Now let's add some money. If Archie used $2 worth of cloth to create a scale model, how much will it cost? Sorry, how much will the cloth cost for the full size flag? So if you're doubling the size, wouldn't you double the cost? Right? Or not right? Do we double the cost? Or do something else? Think so?
No.
Never have an idea what you do?
Yeah.
Not double. What should it be? Okay, let's talk about area, guys. Let's think about it. Okay, so the area again. You guys should know how to find area. You guys are pretty comfortable with that. Because you're using a lot more cloth than double. Think about it. Actually, I'll just put 2 there. Okay, so let's find the area of the small flag, right? 1/2 times the base times the height. You should get 0.75. That's square feet, by the way. Okay, let's talk about the big flag. What's the base there? What's the area? Okay, compared to the small flag, you went from 0.75 to 3. So what do you multiply by 0.75? Or how many times do you have to add 0.75 to get up to 3? Guys, Luke, Adam, do I have to separate you guys? Come on, seriously. 4. Right. So think about it. What if we want to put carpet? I hope we never do that because this is a nice building. We shouldn't put carpet. Just keep it hardwood, keep it the floor. But if I put carpet, right? Okay, let's say this is 20 feet by 30 feet, right? So 600 square feet. But what if we have a bigger room, like courtroom? Have you guys been in that room down there? That's a much bigger room. Let's say it's 40 feet this way and 60 feet that way. I double the sides, but I quadrupled the area. So I need quadruple the cost. So you don't multiply by 2. Even though it seems logical to do that, instead, you multiply by 4. Because again, like, I mean, and when you guys own a house or whatever, if you have to paint something or get carpet or whatever, again, if I said that I want to carpet this room, they would charge for 600 square feet. Core Unum, they charge for 2,400 square feet. That's 4 times the amount. I got to pay 4 times the cost. So it's gonna be $8. So you have to consider area here, not length. Okay, so we're not going to do this activity, but I think you guys get the idea. Let's move on to part D and do the calculation there. Because part C is this activity, I didn't really prepare for that. Let's look at part D. The simplifies reconsidering resizing the flag. Sorry, reconsidering the size of the flag. It's now considering enlarging the flag so that's 3 or 4 times the width of Arch's model. How much would the cloth cost for a simple flag that's 3 times wide? How about 4 times wide? So let's work it out. So let's do 3 times the size. So it's going to be 3 and 4.5. And let's do 4 times the size. Okay, 4 times the size. That's gonna be what? 6, I think. Yeah. Okay. So what I want you guys to do is find the area of each of these. Remember, the area of the small flag was 0.75 square feet. So now this is triple.
Mr. Around B.
Yeah, we're skipping C because I didn't do the activity. I didn't prepare for the activity. And that's quadruple the size. Also, I didn't teach my B period because they had we're interviewing some candidates for the math department, so I got to sit back and relax and watch the lessons. So I didn't prepare this. He did some other stuff. So
Wait, for what department?
math. Yeah, we're hiring a new teacher.
Flags.
We don't know yet. No. No. It's a fair question. No, hold on. No, don't laugh at Braden. I'm laughing at you guys. You guys know what you're talking about. No. In math, we kind of expect teachers to be able to teach all subjects. So like you should have a pretty good range. Like I could teach anything from Algebra 1 to AP Calculus BC. But some people can't do calculus, so it just depends. I don't know. But
Who's leaving?
Ms. Gramet. Wait, did she announce that, or I think? Maybe I should not supposed to. Well, I think it should be fairly public. Well, she's moving. Yeah.
Where?
I don't know. Well, let her share the news. I wasn't sure. It's been out for a month, but I don't know if she's told you guys. But anyway,
That an algebra 2 teacher.
no. Usually when you first start, typically you first start teaching algebra 2. That's typically the case. So, I mean, because it's kind of a more of a standard subject, but it depends. I don't know. Anyhow, let's do this problem. Okay, so what's the area for the triple?
6.75 feet.
Okay, I like that. 6.75. What's the area for the quadruple?
12 feet.
12 feet. Okay. Now, what I want you guys to do is compare the prices. So we're going to compare areas. Sorry, not prices. Because we're doing the area right now. I mean, you can convert the money if you want, but compare the areas, right? So 6.75 divided by 0.75 or 12. So if anyone has a calculator, oh, actually, Anya, you got a calculator, I see. So let's see, or if anyone takes a stab, if they want to guess, they do come out as nice whole numbers. Anya, what do you get? 9. Okay. How about the other one? What's 12 divided by 0.75?
10.
Nope.
7.
16. Okay.
16? Oh.
All right. All right. Now. Okay. Well, the enthusiasm. All right. Here we go. Let's talk about what's happening here. Guys, very important. I want you to see this connection here. So if you triple the side lengths, because you triple the base and you triple the height, you quadruple the base, you quadruple the height. So you're tripling twice. You're quadrupling twice. If you triple twice, what's 3 times 3? If you quadruple twice, what's 4 times 4? So what's happening is this. This is the most important part for today. We'll put this in say or we'll go. Yeah, yellow's kind of hard to read. Let's go hot pink. Here we go. All right. So very important. The linear ratio squared equals the area ratio. Okay, linear means a side length. So if you triple the base, right, or triple the height, whatever, that's linear because that's just a line, right? If we square that, that'll give me the area of the ratio. Sorry, the ratio of the areas, right? So if it was 0.75 originally, the area becomes 9 times that. So that's why for the for doubling, it was 4 times, right? So that's a ratio we're going to be working with often. The linear ratio squared will equal the area ratio, or we call it sometimes a scale factor. The scale, because you're scaling it up by 2 times, 3 times, 4 times, right? Sometimes it calls a scale factor. Sure. Also called scale factor. All right. So with that said, let me have you guys try this next page in your table groups. I'll come and help you guys out. Then we'll talk about the last problem on 870, and I'll let you guys work on homework, okay?
Just 868 whole page.
Full page. 868 and 869. I'll come around and help you guys out.
Area of one shape is 100 times larger than the area of a system city. What's your ratio? Yes, you know it. You're gonna use the back.
Sure, go for it, yeah.
So it was like 100. Wait, what's the?
So now you're giving the area ratio. Guys, going backwards. 867 is going backwards.
Wait, so would it be R squared equals 100?
Wait, yeah.
Area.
Yeah.
Okay. Okay. So the
So
rate.
R equals 10?
Correct.
Yeah.
Right.
Oh,
Yeah. So
I'm sorry.
area 1 to area 2.
I'm sorry.
Area 1. Yeah, area 1 to area 2 equals side 1, side 2 squared. So if one shape is 100 times the other, so let's say area 2 is the length of, let's say area 2 is area of 1, right? Then area 1 would be 100, right?
Wait, and when does this come in handy? Like, is it just for like prices and stuff?
Yeah, for sure. Or when we start talking about similar polygons, or when we start getting the volume, we get to 3-dimensional shapes. Yep.
Makes sense. Beautiful.
So what's gonna be the ratio of these sides, guys? If you square root both sides. Because how do you get rid of a square? You square root. We'll square of 100. So the linear scale factor, which we're calling R, is going to be 10. So, for example, if you have a square, this is a great example, actually. Okay, let's say it's the length of 1 and 1. Length of 10 and 10. What's area here? Look, what's area for this one? How about the small one? So you guys see how the ratio of the areas is 100. What's the ratio of the sides? 10. There we go. So it's just going backwards. What you're doing is you're looking at the area ratio, but you got square root instead of squaring. So if you're given the side lengths, you square to get to the ratio of areas. If you're given areas, go backwards. All right. Okay, now you guys have seen going backward and forward. Try 869, parts A, B, C. So give us a few minutes to do that. We'll check in. Did the girls win?
No, boys won.
Okay. Yeah, Pat won that.
So first,
Did you win last year too?
2, it's 4.
No.
Like they advanced to NorCal, like an automatic bid or something like that.
Isn't it 17?
Which one?
Jocelyn.
I think it's 425.
They said it were like seats to begin, like literally not fun.
Well, he's in 8th grade too, which is like,
Let me clear a screen.
when he was freshman.
Okay. So part A. What did it want?
25.
Hold on. Okay, so you have the areas per shape, right? And the scale factor is 5. So Adam's right. You want to multiply by 25.
I don't see them.
You know why you want to multiply by 25?
I literally did it.
You have a blob, right? You don't have like a square, triangle, or recognizable shape. So all you're given is just the area of this blob.
Yeah.
And you want to find the area of the new blob. And all you're told is that the scale factor to go from the small blob to the big blob is 5. But we know we can't use 5 to 1 for the areas, right?
Yeah.
So we have to square instead.
You can
Well,
find
that
the
makes
area
sense.
ratio on the area
The area ratio is 25, correct? Right, right, right. Yeah, good.
Is it?
Yeah, so what do you guys get for the first part? I'm zoning out too. It's so if you look at the small blob, right? The area is 17.
Yeah.
Okay, the bigger one, I gotta find that area. The problem is that I don't have to, they're all go blob. I don't know, there's no straight edges, right? I don't know any dimensions. If it was a square, fine, great, that's 5 dimensions to work it out. But here's the thing, now it knows the pattern, right? Area. Total scale, the linear scale factor is 5. But if I were to measure maybe like, I don't know, one of the rounded edges, measure a similar rounded edge. But if I find area, what do I do to the scale factor to get to the area ratio? What do we just do, right? We square it, right? What's 5 squared?
25.
So we're gonna multiply something by 25. That's the good.
Yeah, you know, the union of the area, the perimeter would be 5.
Oh,
yeah.
Oh, sorry, say again?
Wait,
What's
what's the link?
Got it. We're working at 7. Good. Excellent. Good. Good. Okay. How are we doing? So what do you get for part A?
17 times 25.
Yeah, because you want to take the scale back multiply by
Yeah,
5.
yeah, yeah.
Okay.
Because 5.
Now move on to part B.
Thanks, Leslie.
Yeah, good. Yeah, part B, you guys should be okay now. Try part B.
Well, 300. It's 441. Yeah, it's 425, right, Nick?
Yeah.
Linear
scale factor is
Your dad's probably part of that.
Yeah, I heard.
That's why you always wear a suit for me.
Is that your dad's company? Cool. Yeah, that's awesome. Yeah, I might check it out. We'll also check one.
Wait,
So let's see. That's great. Yeah. So-
It is,
Yeah,
it
yeah,
is.
yeah. Yeah.
Oh,
So
side one.
so now, what's the scale factor here? 4, right? So what's the area ratio gonna be? 16.
Okay.
So you gotta divide by 16. He's going from now big to small.
That's
Right.
good.
Wait, so
I
did
did
you
that
put it,
before you, I did that before you.
56 over 16?
You said you would stop
Right.
us 5
Right,
times.
right.
I wouldn't find it out if it's.
Because what's the ratio of the sides? 4-to-1, right? But then, so that makes the area ratio 16.
Yeah.
And you got 656.
Yeah, I can represent MJ too.
Oh, yeah.
Okay, hopefully you guys, as I've spoken with many of you guys, I think we're making sense of parts A and B. So yeah, we see that if the scale factor is 5, the area ratio is 5 squared. So for this guy, I gotta do 17 times 25. And what was that exact? Did someone compute that? Is it
425.
425? Yeah, it sounds right. Now you're going the other direction here. So scale factor for the linear ratio is 4-to-1. Hey guys, let's be silent. Thanks. Area ratio is 16. Well, I'm gonna do. You guys are gonna do C together. I'm gonna come around and help you. I'm not gonna give you C just yet. So you gotta do 656, which is 41 units squared. Okay, does that make sense? We're okay with that? We're cool? Okay. Go and try part C in your table of groups again. Yeah, we need 656 divided by 16. Yeah, because we're going to try part C. Hopefully you guys can make sense of that one and figure out the correction there. Yeah, okay. You got it, Emily? Yeah. Yeah, good. Yeah. Nick, go ahead.
It should be 1/4.
Correct. Right.
Because 1/2 times 1/2.
Right. So yeah, let's take a look at part C. So again, think about it. Let's say we're downstairs at Corunum, which is actually directly below this room, right? Corunum, I think, is twice the size of this room. Quite long, quite bigger. Man, probably triple or quadruple, but anyhow, or the Hearth. The Hearth's a little bigger, but let's just talk about Corunum. So if someone told you, hey, it's gonna cost $1,000 to put carpets in Corunum, and then you think about, oh, Corunum is twice as long, twice as wide. Okay, then it should cost them 1/4 as much, right? Because if I'm reducing the height or the width and the length by half each, in this case, same thing. So you got to divide by 4, not divide by 2. $200, yeah.
I just saved myself.
All right, so that should be $200. $200 because each dimension. Actually, let me tie this up, guys. We better. Okay, let me finish typing this, and then you guys can move on to the last page. All right.
We know it's not right. That is 4 times. This is 4 times. We know this thing. We know this one. If I call this 4 times, 4 times less. So what would you do? It's 200. Nick.
Mr. Can I go smaller?
Hmm?
Huh? Your boy.
Okay, guys, quiet. All right. So again, it's $200 because each dimension is cut in half, right? That means that the new area is a fourth of the original area, right? Because if you do 1/2 times 1/2, you multiply the numerators, multiply the denominators, you get 1/4. Therefore, the original cost is cut by 1/4 as well. So we're okay with that? Cool. All right. Last one, and then you guys can work on homework. I do want you being productive when you're doing homework. So no playing video games.
Okay.
Right.
Okay, everyone.
All right. Go and try 870. How's the area increase? So what I want you guys to do is make a prediction. Make a prediction. And then calculate area 1 or area small. Area large.
That's the obvious and they say that how should be this going to see board. Ooh, gosh, what? So then you can say one of them is less than. They're like. So one triangle, then you can say. So 80. Right, that's 80. Yeah, 80. So we do that. Yeah, they're doing it. Makes sense. Huh? No, I'm just gonna put 500. So then that's, yeah, I mean, there has. So then it's. Like, times 9. So then it's 4,000. Wait, so you're asking me? So I'm telling you.
Say some up.
Sure. Okay, I've kind of teed this up for you guys. So figure out H1 and H2. B1, B2 are easy. You're in at 1030. Griff, good. Oh, okay. You're stretching. No worries. All good. So you know B1 and B2 are 10 and 30, right? Because just, who says, first of all, what's your prediction? If you triple, how's the area going to increase? Based on what we've been talking about today. Is the area going to triple or something else? The area's not going to triple, guys.
Where?
It's gonna.
Well,
4.
So what's 3 squared?
9. That's 3.
So 9 times. It's going to be 9 times larger.
Yeah, wait.
You're doing 3 squared.
Would it be 9?
So let's prove it. Okay. So if the base one is 10, guys, what's the height of the first one? You guys should know this, 36/90 ratios. 10, 5, and 5√3. Very good. Given that, what's height 2? Height 2? So if I find area 1, that would be 25√3. And that'd be 225√3. Of course, you got to multiply each by 6. Multiply by 6. Multiply by 6. So if you work them out, because you have 6 triangles. No, just to get to the area that each hexagon. That's all. That's all I'm doing. It's 25√3. Yeah, my handwriting sucks. So apologies. So you should get 150√3 for the small hexagon, you should get 14. Well, what was that going to be? 12, 1350 root 3. Anthony, go ahead. Yeah,
I
sorry.
did trig.
Was that sorry?
I did trig for the.
That's fine.
Okay.
Yeah, if you got decimals, that's fine. So when you compare it, you have to multiply. You have to multiply by 9 to get to the other one. So that's what's happening there. Okay, so just to recap really quickly here. Okay, so we're okay at that? We're good? All right. So just to recap. So Pierce, can you read the last part? It says ratios of similarity. I know he's a good public reader. I'm trying to make him laugh, please. Okay, good. You got it. Guys, let him talk. Nick, stop. Good.
Is there a comparison of single dimension which is often this value is represented with the letter P?
If keep going, please. Finish off.
For example, notice that the two triangles are right. These correspond to when you do big and 9 and 6. It can be stated that part of it.
Right. So what's happening here is that obviously we're not cutting the triangle in half or by third or fourth. It's just some weird fraction. But the area ratio, if this is what I'm dealing with, right? I would just take the scale factor, which we're calling R. I'd square it, which of course would be 9/4. So if this had an area of 4, sorry, my bad. If this had an area of 4, I'll call it area 1 is 4, then area 2 would be 9. Because the linear scale factor is 3 to 2. So that's what we need to talk about. Linear scale factor, that ratio, square it. Or sorry, yeah, so always square it, whatever the ratio is. All right, homework is this, homework 18. You guys, and the last class actually got pretty far too. So you guys can get far. It's right here. Homework 18. And 872 is a little tricky. So I don't mind if you guys kind of look at the answer key and kind of cheat a little bit. That's okay. Because 872 is a little tricky. But you have a bunch of other problems here. So let's try to knock this out. Okay. And that's it. We're all done.
I use the restroom.
Sure, no problem.
Thank you.